China's grand ambition knows no bounds as it embarks on an extraordinary endeavour. The $62 billion South-North Water Transfer Project. Water has always been a big deal in China's history. Managing floods, irrigation systems, and water transport has shaped their civilization and sparked incredible innovations. Fast forward to today, and China is taking on its grandest water project yet. They're building an intricate network of canals, aqueducts, and mind-blowing tunnels to quench the thirst of the parched northern regions. If you're wondering why China is taking on such a monumental project, join us as we explore how important this audacious engineering marvel is in maintaining the country's water landscape. We'll dive deep into the challenges, ambitions, and incredible feats of construction that define this project. So, prepare to be amazed by the sheer scale and ingenuity of this water transfer project, and how the Chinese engineers shock the American president and other engineers worldwide. China's geography has profoundly shaped its destiny, presenting a unique mix of advantages and challenges. The majestic Yangtze and Yellow River systems flowing across the land from west to east have been pivotal in sustaining human civilizations for millennia. The fertile floodplains in eastern China have nurtured thriving agricultural communities, creating an abundant food source and supporting a growing population. It's no wonder that the Yellow River Valley has earned its reputation as one of the world's most productive agricultural regions. However, a different landscape emerges as we venture north and explore the far western parts of China. Here, dryness and mountainous terrain dominate the scene. Vast expanses of desert, such as the 𝗥𝘀𝘁𝗁𝗏 and 𝗘𝗶𝘃𝗁𝗏, stretch across the northern regions, posing challenges for human settlement and agricultural activities. The formidable Himalayas and the vast Tibetan Plateau further contribute to the region's rugged and inhospitable nature. Unsurprisingly, these areas still need to be more populated and largely unsuitable for large-scale agriculture. To put things into perspective, imagine drawing an imaginary line across China, dividing it into east and west. Astonishingly, approximately 94% of the country's population resides east of this line, where the advantages of fertile floodplains and favorable climatic conditions prevail. Yet, as China's population boomed and urbanization accelerated during the mid-20th century, the northern region faced pressing challenges. Rapid growth in cities like Beijing strained the availability of vital resources, particularly water. Groundwater became a lifeline, supporting the needs of urban and industrial development. However, with the escalating demands of a booming population, the once abundant groundwater reserves began to dwindle, reaching unsustainable levels. This overexploitation of a limited freshwater source severely threatened the region's water security. Adding to these concerns, expanding the Gobi Desert in China's Inner Mongolia autonomous region brought forth a new set of challenges. Frequent dust and sandstorms, carried by strong winds, plagued the northern cities, affecting air quality and exacerbating water scarcity. Desertification, driven by factors such as deforestation, climate change, and the depletion of underground water sources, encroached upon grasslands at an alarming rate. Each year, approximately 3,600 square kilometers of grasslands fall victim to the relentless encroachment of the desert. By the early 1950s, it became evident that northern China was facing an impending water crisis. Rapid urban expansion, a surging population, and dwindling water sources painted a grim picture for the region's future. The challenge was clear: how to sustain the livelihoods of hundreds of millions of people in a historically dry area. Today, China is still grappling with a pressing issue affecting its nation: a severe scarcity of water sources. The distribution of these resources within China is highly uneven, with the water-rich south contrasting starkly with the water-deprived north. This scarcity is intensified by China's staggering population of over 1.3 billion people, a significant portion of which resides in the relatively arid regions of northern China, specifically the 𝗤滟滬𝗁 river basins. Also compounding the problem is the low water productivity, particularly in the agricultural and rapidly expanding industrial and energy sectors. Climate change further compounds the issue, disrupting weather patterns and accelerating the melting of glaciers, leading to reduced surface water resources. Adding to the challenge is the pervasive pollution of China's surface water resources. Industrial and domestic wastewater discharge has extensively contaminated rivers, affecting approximately 90% of urban rivers. This pollution poses health risks to the population and exacerbates water shortages, pushing communities to rely increasingly on groundwater. Consequently, critical rivers, lakes, and wetlands are drying up, and water tables are declining, causing land subsidence in certain areas. The consequences of water scarcity are far-reaching, impacting China's economic productivity. Reduced river flows hamper hydropower generation and sabotages the expansion of water-dependent industries, such as coal mining, petroleum refining, steel production, and high-tech sectors like semiconductors. Recognizing the situation's urgency, China's policymakers have prioritized addressing the country's water supply challenges. Premier Wen Jiabao has aptly described China's water deficit as threatening the nation's survival. Throughout history, China has turned to engineering solutions to tackle water shortages, employing techniques that date back to the Han Dynasty. Chain pumps to transport water from lower to higher elevations for irrigation and urban water supply. Mao Zedong continued this legacy, harnessing modern technologies to ensure sufficient irrigation water for agriculture in the dry northern regions. Tube wells, powered by gas or electric pumps, were constructed to extract water from aquifers, sustaining agricultural production. However, the unsustainable nature of these pumping practices has become evident, with rapidly declining groundwater levels and rivers experiencing dry spells for significant durations. The need to address this water scarcity has never been more urgent, and China's survival and economic prosperity hinge on finding sustainable solutions. And that's where the Water Transfer Project comes in. In 1952, the leaders of the newly established People's Republic of China recognized the urgent need to address the water scarcity issue plaguing the dry northern regions. Their proposed solution was bold, yet practical, transferring water from the water-rich southern parts of the country to the parched north. They compared it to borrow some water from the south, where it was abundant, to alleviate the water shortages in the north. It took several decades of meticulous planning and extensive research to turn this visionary concept into a reality. Finally, in 2002, the State Council of China gave its official endorsement, ushering in a great initiative known as the South-North Water Transfer Project. This ambitious undertaking aimed to construct an intricate network of aqueducts, tunnels, reservoirs, and dams to transport precious fresh water from the south to the water-starved north. The South-North Water Transfer Project comprised three main canal systems, each with its route: the eastern central and western routes. Together, they formed a comprehensive water delivery infrastructure spanning thousands of kilometers, bringing much-needed relief to the northern regions. The project's scale and complexity were truly unprecedented, reflecting China's determination to overcome the challenges posed by water scarcity. With the project's approval, China embarked on a monumental journey to harness its engineering prowess and tackle one of the nation's most pressing environmental challenges. The South-to-North Water Transfer Project might sound simple in theory. Still, it is a monumental undertaking that involves the collaboration of various entities and organizations to ensure its successful implementation. The project is overseen by the South-to-North Water Transfer Project Company, which has been entrusted with the responsibility of managing and coordinating the different aspects of the project. Throughout the project's extensive 50-year planning and research phase, numerous ministries, organizations, and institutes across China have significantly shaped and refined the project framework. Their collective efforts have been instrumental in transforming Mao's initial concept into a comprehensive and well-coordinated project set to address China's water scarcity challenges on an unprecedented scale. But how exactly does the transfer project work? The eastern route of the South-North Water Transfer Project begins its journey from the vicinity of Yangzhou, strategically tapping into a significant branch of the mighty Yangtze River. A large pumping station, though aging, diligently pumps water from the Yangtze and directs it into the renowned Zhanghang Grand Canal to facilitate water transfer. This remarkable feat of engineering, stretching as the world's longest fully constructed artificial waterway, is a crucial conduit for the freshwater flow. Continuing its course, the water is channeled through an impressive underground tunnel that spans beneath the majestic Yellow River. This subterranean passage ensures a seamless and efficient water transfer between the two iconic rivers. Upon emerging from the tunnel, the water finds its way through a series of aqueducts, carefully navigating the terrain to reach its ultimate destination, the vibrant coastal city of Tianjin, situated northwest of the nation's capital, Beijing. Construction of this ambitious endeavor commenced in 2002, with an initial target to deliver fresh water to Tianjin by 2013. However, as with any large-scale project, there were unforeseen challenges and construction delays, causing a postponement of over 4 years. Finally, in 2017, the long-awaited moment arrived, and fresh water from the eastern route reached Tianjin, bringing an estimated annual volume of 1 billion cubic meters of water. This significant freshwater supply has had a transformative impact on the lives of approximately 10 million residents in Tianjin. It provides them with a reliable source of clean water and supports various sectors that depend on it, including industry, agriculture, and municipal services. Next, we have the central route. The central route of the South-North Water Transfer Project presented its unique set of challenges, separate from its eastern counterpart. Unlike the eastern route, which leveraged existing infrastructure, the central route required extensive construction from scratch. The journey of the central route begins at the Danjiangkou Reservoir, a crucial water source in central China. To ensure a smooth downstream flow towards the north, the Danjiangkou Dam underwent a remarkable elevation of up to 15 meters. This elevation adjustment allowed the water level within the reservoir to rise naturally, eliminating the need for pumping stations and enabling the water to flow effortlessly through the canals and aqueducts. However, this elevation adjustment came at a cost. Over 300,000 individuals from the Hubei and Henan provinces were relocated to accommodate the expanded reservoir and the construction of canals. The central route extends through the network of artificial canals and aqueducts that traverse the vast expanse of the Chinese Central Plain. Notably, the 𝗘滬 aqueduct stretches over 12 kilometers, gracefully carrying the water above the surface of the 𝗘滬River. Finally, after a long journey, the central route reaches its ultimate destination, Beijing, the bustling capital of China. Construction on the central route was completed in 2014, covering an impressive length of over 1,200 kilometers. However, the diversion of approximately 1/3 of the water flow from the Han River, which supplies fresh water to millions of people, posed significant challenges. To address this issue, the Chinese government announced an ambitious plan in July 2022 to construct a massive underground tunnel. This extraordinary tunnel, located 1 kilometer beneath the surface, would connect the Three Gorges Dam to the Han River, subsequently linking with the central route leading to Beijing. Once realized, this remarkable feat of engineering would claim the title of the longest and deepest artificial waterway ever constructed. By 2030, the central route will transfer an impressive annual volume of up to 12 cubic kilometers of water. This substantial contribution is equivalent to approximately 1/3 of the total capacity of the Three Gorges Reservoir, a testament to the scale and ambition of China's South-North Water Transfer Project. While the eastern and central routes of China's South-North Water Transfer Project are well underway, the western route is still in the planning phase, poised to be the most challenging of the three. The proposed design for the western route involves creating an intricate network of waterways and tunnels connecting the Yangtze River to the Yellow River, traversing the daunting 𝗘𝘀𝘁𝗁 Tibet Plateau. Known for its extreme elevation of 3 to 5 kilometers above sea level, the region's rugged topography and harsh climate pose significant obstacles to construction, requiring engineers to navigate treacherous mountainous terrain. The completion of the western route is projected to occur around 2050, but the magnitude of the undertaking should not be underestimated. Once finished, the western route has the potential to supply a staggering 17 cubic kilometers of fresh water annually to the northern provinces of China. This massive volume could meet the water needs of a combined population of nearly 100 million people residing along its trajectory. It is worth noting that while there have been unofficial proposals in the past to divert water from trans-boundary rivers originating in China, such as the 𝗪𝘁𝗄𝗏 and Mekong rivers, these plans have yet to be officially incorporated into the project's current scope. Nevertheless, concerns raised by neighboring countries, such as India, regarding the potential manipulation of water flows highlight the geopolitical complexities associated with such a colossal water transfer project. The financial costs associated with the South-North Water Transfer Project are quite substantial. The project's construction and ongoing maintenance have significantly burdened the Chinese government, amounting to billions of dollars. The estimated total cost of the project is approximately $62 billion, a staggering sum that reflects the scale and complexity of the endeavor. This figure needs to account for the future expenses required to maintain and operate the extensive network of canals, aqueducts, dams, tunnels, and reservoirs spanning over 3,000 kilometers. Despite these significant investments and efforts, the South-North Water Transfer Project has yet to fully achieve its original objective of providing clean water to the water-scarce regions of northern China. The project's completion remains a complex and ongoing process, and its long-term effectiveness and sustainability are subjects of continued evaluation and scrutiny. As China explores alternative solutions, such as seawater desalination, to supplement its water supply, the construction of the South-North Water Transfer Project continues. The government's ongoing investment and increased funding allocation demonstrate their unwavering determination to see the project through. What do you think of China's water transfer project as a solution to water scarcity? Do you have any ideas for an alternative solution? Tell us in the comments below.